Hi everyone, you're welcome once again to another session of learning. Today in our mathematics class we'll be looking into introduction of fractions. Actually, this week it will be like an introduction to fractions because fraction is a very wide concept, and I think it runs for about 3 weeks in the curriculum. So this week being the first part, I think it will be safe to call it the introduction to fractions, because we're going to be looking at the parts of fraction that doesn't involve so much calculation, you understand? Like the part of it that just introduces us to fraction and to some basic things about fractions. So before we go on, let's look at fraction. What actually do we mean by fraction? What is fraction? Fraction actually means parts of a whole. Parts of a whole. That means something that is not full, that is not complete, is referred to fraction. Part of something that is complete or whole. Let's do a visual illustration. Please pardon my drawing, but let's assume this is maybe bread, right? A loaf of bread. Let's take this to be a loaf of bread. This is one loaf of bread, okay? One loaf. And because it is one, it is full, this is whole. Whole, that means it is complete, okay? Is total, whole. Now let's look at a situation where this loaf of bread needs to be shared among, let's start with 2 people. So you find out that it goes right there in the middle. Now if it is cut like this, then this part is no longer whole. So you see what I wrote there? Not whole. And this part too is, this part too is not whole. No part is whole anymore, because this is part of the full bread, and this other side is also part of the full bread. So this that is not a whole, that is a part of this full bread, is known as a fraction. It's a fraction, and this side is also what? A fraction. So a fraction simply means a part of a whole. It may not be the half that is out of it, it could be from here. But any part of this full bread that is cut out is a fraction of the bread. Once a part is cut out, even the part that is left is also a fraction. It's just that one fraction may be bigger than the other. So once it is not whole, once it is not full, once it is not complete, it is what? A fraction. Another example we can look at is, let's look at this, a pizza, right? Normally a pizza is always shared into 8 parts, right? Okay, let's take this to be a pizza with all the things they put on top. So let's take this to be a pizza. Now this full pizza, this round pizza is whole. Everything you see here is whole. That means it is full, it is complete, right? But now let's take out a portion of this pizza, like one slice. Let's take out, let's take this slice out. Okay, let's take out from here. Okay, I just want the portion that will be visible. Now we have taken this part out. This is the part we have taken out. It is here. Sorry, let me close that back. Let me take from here so that we can easily see what we have taken out. Is it clear? So we've taken out this part of the pizza. We've taken out the slice. Now this slice that is out is a part of this whole, is a part of this whole, is one part of these 8 pieces of pizza. So this is a fraction. And because a part has already left the whole pizza, the remaining one, even though it looks large and all of that, is no longer whole. This is no longer whole because something has left it. It's no longer complete. So this also is fraction. Though this fraction is bigger than the one that is removed. This other fraction that is remaining is bigger than the fraction that is removed. But both are now fractions because this one is not complete and this one is not complete. And we said that fraction means what? Part of a whole. Now, for instance, if we are going to represent this fraction now, if we're going to represent this fraction that we pulled out of the pizza, this one piece of pizza, this one piece of pizza in fraction will be written as just 1 out of, how many pizzas are there, pieces of pizza are there all in this whole? We have 8 pieces. We have 8 pieces because the whole pizza includes this one that was pulled out. So to show this in the fraction form, the part that was pulled out, which is just 1, will be written out of. That line signifies out of. Okay, some people call it over the total number of pizza pieces that you have, which is 1, 2, 3, 4, 5, 6, 7, and 8. You're going to include that part you removed because that is what forms the whole. Fraction is part of the whole. This is the part, which is 1, and the 8 is the whole. 1 out of 8. Part of a whole. Assuming it's 2 parts that are removed, maybe this second part is also removed. Okay? That means if it's 2 parts that is removed, your fraction will be 2 parts out of 8 parts. Right? If they remove 3 parts, it will be 3 out of 8. 3 out of 8. So all these numbers we are indicating here, we are showing here, they are all what? Fractions. Fraction simply means part of a whole. Now let's go back to the bread that we use as our example, the first example. You know, we said assume this bread is a whole loaf, right? And then at some point it gets shred in the middle into 2 parts. What happens? If you are going to talk about any of the parts, that part you're talking about is simply 1 out of, how many parts in all? 2 parts. 1 out of 2 parts. So I hope by now we've been able to establish what a fraction is. A fraction simply means a part of a whole. Okay, so next we are going to take a look at the types of fractions that we have. We have different types of fractions. Okay, we have different types of fractions. So let's look at the types first, and then we go on to maybe the names of fractions. Yeah, we'll go to the names of fractions. But first, let's look at types of fractions. Types of fractions. Now let's quickly look at something. In the example that we gave with the pizza, we said, I don't mind drawing that back. So we have our pizza back, right? So this is our pizza with all the toppings. We have our pizza back. Okay, so we get a pizza back. Now we said, assuming we move out one part of this pizza, we remove one part of this pizza, that's the part we have removed, right? So now we say that this When this part was here, it was a whole. But now this one part has been removed, or one piece has been removed. This is no longer whole, and this is no longer whole. Okay? Now remember we said that fraction is part of a whole. So to represent this now, this is one part. Remember, this is one part. Out of how many? 1, 2, 3, 4, 5, 6, 7, 8. This part that was removed originally came from here, and with this part that is removed, that's the only way you can call this pizza a whole. So to represent it, it has to be one piece out of a total of everything, which is 8. Okay? So if you remove one pizza, it's 1 out of 8. Now if two pizzas or two pieces of pizza, if two pieces of pizza are removed, it becomes, that is, these two will give you 2 out of 8. You see that? 1, 2, 3, 4, 5, 6, 7, 8. You won't say 2 out of 6. In the case of the first one, you will say 1 out of 7. No, it is 1 out of the total number, 1 out of the whole, 1 out of everything. Okay? Now here is what I quickly want to show us now. Fraction is always represented like this. You have one number on top, you have a line in middle, and then you have a number below. Okay? This is always how fractions are represented. Now, this number on top is known as the numerator, while this number below is known as the denominator. Okay? Very important. A fraction is always formed by two numbers, one at the top and one below. The number at the top is known as the numerator, while the number below is called the denominator. Okay? So I just quickly wanted to show us that. Now let's move on to types of fraction. Okay? Let's quickly move on to types of fractions. So looking at types of fractions, we have proper fraction. We look at them briefly. Proper fractions, improper fractions, improper fractions. Then we have like and unlike fractions. We will stop here for now. There are other types, like fractions, then lastly unlike fractions. I just want us to stop here. We have equivalent fractions and the rest, but I don't want us to go there because that is another topic of its own, on its own. We're going to go there. But for now, I would just like us to stop here because this is part of the introductory section of fractions. You know, it's the lighter part of fractions. So I wouldn't want us to delve into the hard part. So let's start with this for now. So you have proper fraction, you have the improper, you have the like fraction and the unlike fraction. Okay? There's also the one we call mixed number. Let me just quickly introduce it here, even though we might not talk much about it. Mixed fractions, or some people call it mixed numbers. Mixed numbers. Okay? So for proper fractions, what do we mean by proper fraction? In the first place, what does the word proper mean? In the ordinary, as an ordinary word, in the regular or normal context, what does proper mean? Proper means what is right. Proper means what ought to be. Okay? What is acceptable. Alright, so when you say proper fractions, it means fractions that are in the correct order, in the right order. And what is the right order for fractions? The right order for fractions is that the smaller number has to be at the top of a bigger number. So that is the correct order of a fraction. So this, when you see the upper number smaller than the number beneath, it is a proper fraction. That is, when the numerator is smaller than the denominator, the fraction is proper fraction. It's in the correct order. Now here is the way I help my kids to remember this. I'll tell them something about the numerator being the baby and the denominator being the mommy. Okay? This is just to help you to remember them so that you don't get confused about proper and improper fractions. I'm going to make a connection, okay? I'll make a connection between these, the proper fractions and the baby and mommy, the improper fraction and the baby and mommy, so that you'll be able to easily tell which is which. So now, baby normally is carried by mommy. So this is what I tell my students. When mommy is on the carrying the baby on top, it is what? Proper. It is right. It is okay. Because mommy, the denominator, is actually supposed to carry the baby, the numerator. Mommy should be bigger than baby. Mommy should be heavier than baby. So mommy should carry baby. So the denominator is the mommy and the numerator is the baby. And when it's this way, it is the correct order. When it is this way, it is proper. So proper fraction is when the numerator is smaller than the denominator. Numerator is smaller than the denominator. So we could just put an example like here, put 2 out of 3. The numerator is smaller than the denominator. It's proper. Now, but when you have a case where mommy is now being carried by baby, does it look normal? Mommy is supposed to be carrying the baby. Mommy should be bigger than the baby. That's the case of proper fraction. But when you have a number like 3 out of 2, when you have the numerator being bigger than the denominator, it is not proper. Baby cannot be carrying mommy. The bigger number is the mommy, right? Now you are telling us that the baby is carrying the mommy. It's not proper. So in a case like this, you call it improper fraction. Improper fraction, where denominator is smaller. Denominator is smaller than the numerator. So an example will be 3 out of 2. It's an example of improper fraction. It's not proper. It's not normal. Baby cannot carry mommy. Improper. When the number on top is bigger than the number below. When the numerator is bigger than the denominator, or when the denominator is smaller than the numerator, it is improper. It's not proper. Baby cannot carry mommy. Okay? So the next one we're going to look at is like fractions. What do we mean by like fractions? These are fractions with the same denominator. Let me just write the n. Okay. Fractions with the same denominator. I can give you an example with that. Let me just move this down a bit. An example of like fractions will be 1 over 3 and maybe 2 over 3. Both of them have 3 as denominators. So 1 over 3 and 2 over 3 are like fractions. Another example will be maybe 3 over 5 and 4 out of 5. This is also like fractions. Okay, so the next one is unlike. Okay, unlike fractions are those fractions with different denominator. Fractions with different denominators. So for example, you have 1 over 3 and maybe 2 over 5. They are not the same denominator. And then another one will be, let's say, 3 over 7 and 1 over 8. They are not like fractions. They are unlike fractions. They are unlike fractions. So let's quickly go over this. And then we have mixed numbers. I will talk about that shortly. But then let's quickly go over what we've learned. Types of fraction. We have the proper fractions, where the numerator is smaller than the denominator, and that is what is expected. That the number under is bigger than the number on top. Okay? I say mommy is under and baby is on top. Mommy ought to carry baby, so it is proper. But improper fractions means it is not proper, it is not right. And what is not right? For baby to carry mommy. When the number below, when the denominator is smaller than the number on top, which is the numerator, it is not proper. That is improper fraction. And then we have like fractions. Like fractions are those fractions that have the same number under. They have the same denominators. So 1 over 3 and 2 over 3 are like fractions because they have the same denominators, 3, 3. The same thing as 3 over 5 and 4 over 5. They have the same denominators, 5, 5. So they are like fractions. While unlike fractions are those fractions with different denominators. They have different denominators. Example is 1 over 3 and 2 over 5. 3 and 5 are different denominators. So these fractions, 1 over 3 and 2 over 5, are unlike fractions. Another example is 3 over 7 and 1 over 8. 7 and 8 are different denominators. So 3 over 7 and 1 over 8 are unlike fractions. So the last fraction that we just mentioned, we might not write anything in details, we'll come across it later, is mixed fractions, and some people call it mixed numbers. Whichever, they are referring to the same thing. And what does mixed fraction mean? Mixed fraction simply refers to a combination of whole numbers, whole plus fraction. Let me write it that way. Whole plus fraction. Is it clear? So mixed numbers or mixed fractions simply refers to whole numbers plus fraction. When you write whole numbers and fractions together, it is mixed fraction or mixed number. So an example will be, let me just find the space here. An example of this will be maybe 1 whole number, 2 over 3. So you see here that 1 is a full number, it's a complete number, while 2 out of 3 is a fraction. So when these two combine together, you call it mixed fraction or mixed numbers. Another example is 3 over 8. This is another mixed fraction. 3 here, the first 3 is a whole number, while 3 out of 8 is a fraction. So when you join whole numbers and fractions together, you call it mixed fraction or mixed numbers. So the next aspect we're going to look at is names of fractions. How do we call fractions? You know, when we looked at the aspects of types of fraction just now, I was just calling them in a way that wasn't really the correct way of calling them. Like I would say 1 over 2, 1 out of 3 and stuff like that. Not that they are totally wrong, but then they have names. And that's what we're going to look at next. The names of different fractions and how we can also name those that will probably not be represented here because fractions are very large. It's a very large group of numbers. But we're just going to use these ones that we have here to see how we can name fractions generally. Okay, let me change some of these figures from 1 to something else. Okay, let's just change some of the numbers so that it won't be like we run into challenges or problems when we encounter different numbers from 1. All right, so the first one that we have here is the fraction 1 out of 2. Okay, 1 out of 2. The way we refer to this fraction is half. This fraction is called half. 1 out of 2. You know, sometimes we say 1 over 2, but the real name is half. And then the next one is 1 out of 3, 1 portion out of 3 parts, 3 whole. Okay, so this one is called 1/3. Okay, so please, we use a lot of ordinal numbers here when we are naming fractions, with like first, second, third. Those are ordinal numbers, 4th, 5th, 6th, 7th, 8th, just like that. We use those numbers a lot. So this is 1/3, 1/3. And then this one that is 1 over 4 is, you can either call it 1/4, that's 1 out of 4, or you can call it 1/4. Okay, so this is 1/4, that's 1 out of 4 parts, or 1/4. This is 1 out of 3 parts, you call it 1/3. 1/3. 1 out of 2 parts is called half. Okay, so the next one is 2 out of 5 parts. 2 out of 5 parts is called 2/5. Remember, I told us we use a lot of ordinal numbers. 5th, that's the ordinal number for 5. Like when you are talking about position, like it's in the first position, second position, third position, just like that. So the number on top is called its normal name. The numerator is called or is named with its actual name as a number, but then the denominator carries the ordinal name, the name of the ordinal number. Okay, so the top one is the normal name, while the bottom one, the denominator, carries the ordinal name. So 5, the name you call it in ordinal number is 5th. So you have 2/5. 2/5. That's how you call 2 over 5. And then the next one here is 1 over 6. 1 over 6 is 1/6. 1/6. Okay? And then the next one you have is 1 over 7. Let's change this to maybe 5. Let's do 5. At least let's have something a bit different from 1. Okay, now 5 out of 7 is called the top name, normal. 5, you put your hyphen. 5/7. But the denominator must bear the ordinal name. Then number 7, you have 1 out of 8. This is 1/8. See, 8? That's not the number, that's 8th. 8th. That's the ordinal name. Let's change this to 4. 4 out of 9 is 4/9. 4/9. Sounds strange, right? Yeah, but that's the way they are named. And then number 9 is 3/10. 3/10 with the next, sorry. 5/7 with the next. Okay, 3/10. And the last one is 2/12. 2/12. Okay. The important thing to note here is you call the number on top its normal name, and then the number beneath, which is the denominator, is called in the ordinal form, like first, second, third, fourth, fifth, sixth, seventh. But like in the case of half, half is special. You can't say 1 second. It doesn't follow. Half is half. 1 out of 2 is half. Okay, and then for 1 out of 4, you can call it 1/4 or you call it 1/4, or some people will simply call it a quarter. A quarter. Okay, so it means the same thing. And yeah, that's basically what it is. So just note the names at the top are called the normal names and the down the ordinal names. So you can name any fraction you see, really, once you follow these rules. Okay, you can name any fraction at all. So the next part we're going to look at is comparing like fractions. Comparing like fractions. Remember earlier when we looked at types of fractions, we mentioned like fractions, and we say that like fractions are those fractions that have similar denominators. Those fractions that their denominators are the same. So comparing them is, you're going to check which of them is bigger and which of them is smaller. And remember, in our previous lesson, we looked at the signs for comparison that we use. We have this less than sign, greater than sign, and the equal to sign. We'll be using this in comparing our fractions, okay? So instead of writing this and this is bigger, you write long. No, in mathematics, we use symbols a lot, to represent things. We use symbol. We don't write so much in numeracy. It is all about numbers and symbols. Okay, so here we have 5. Okay, let's call this rename, not 5 out of 7 or 6 out of 7. No, so this is 5/7, 5/7, and the other is 6/7. 5/7 and 6/7. So how do we compare these numbers? In comparing like fractions, simply compare the numerators. That's all. The numerators are the numbers at the top, right? So since they have the same denominators, all you need to compare to figure out which is smaller or which is bigger is check the numerators. So you have them there. You look at them, which one is bigger or which one is smaller, depending on what you're looking for. So here we see 5, we see 6. And we know normally that from our knowledge of numbers that 5 is smaller than 6, right? 5 is smaller than 6. So whenever you find the numerator that is smaller, that means that fraction is smaller. So simply compare the numerators, comma, and the fraction with the smaller numerator or let's say the fraction with the bigger numerator is the bigger fraction. Larger or bigger fraction. Okay, so simply compare the numerators, that is the numbers at the top, and the fraction that has the bigger numerator, that fraction is larger. So in this case, we see that 6 is bigger than 5. That means 6/7 is bigger than 5/7. 6/7 is bigger than 5/7. Now, if you look at the symbol, you see that the greedy crocodile is opening his mouth towards the larger number. So like I mentioned before, you can't just say if he faces this way, it's bigger, if he faces that way. No, it depends on where your larger number is and where your smaller number is. If you're writing your smaller number first, the mouth of the crocodile closes towards that number and opens towards the other way. Okay, so here we can see that 6/7 is written last, and as a result, the mouth of the crocodile is open towards the right. But in some cases, if you write the bigger number first, that means the mouth of the crocodile will be open towards the left. Okay, So this is an example. Let's take a second example before we check something else. So the next example we're going to look at is 7/9 and 5/9. So check between these two fractions. 7/9 is actually 7 out of 9, and 5/9 is 5 out of 9 portions. So we're going to look which of these is larger. Now remember what we said, since both have the same denominators, what you need to look at to find out which is bigger or which is smaller is simply look at their numerators, that is the numbers at the top. So if you look at the numbers at the top, we have 7 and we have 5. Now remember what we said earlier. We said that whatever fraction has the larger numerator, that fraction is the bigger one. Okay, so looking at these two now, we can tell that 7/9, which is 7 portions out of 9, is larger. So you write a 7/9, and the mouth of the crocodile opens this way, and you write your 5/9. So 7 out of 9 is bigger than 5 out of 9. And it's actually logic. How? Assuming we have a pizza that is shared into 9 parts, right? I like to illustrate with pizza. 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's split this further. Alright, so we have 9 parts there. Assuming we have a pizza that is shared into 9 parts, and then one person comes and is giving 7 portions, okay, out of 9. And then there is someone else that comes, and that person is only giving 5 portions out of 9. So who has a larger portion? This is 5. Okay, let's start with 5. I think it makes more sense. Now the first person comes and they bring out a pizza with 9 pieces and give the person 5 pieces out of the 9 pieces of pizza. And then another person comes, they give the person 7. Now look at the total surface area. Who gets more pizza? Who gets larger size? Is the person that got 7 out of the 9 parts. So 7 out of 9 is greater than 5 out of 9. So comparing like fraction is very easy. All you need to do is just check their numerators and see which is bigger or which is smaller, depending on what you are looking for. Okay, so the next aspect we're going to look at is the addition and subtraction of like fractions. Okay, so here is an example. 2/5 plus 1/5. 2/5 plus 1/5. So when we are adding like fractions, what do? This is very simple and straightforward. Remember we mentioned earlier that when we want to check what fraction is bigger or smaller, we only look at the numerators because the denominators are the same. Okay, this only happens for like fractions, that is fractions that have the same denominators. You only look at the numerator to determine which is bigger and which is smaller. Almost the same thing applies when you want to do addition of like fractions. You only add the numerators, the numbers at the top. Okay, you only add the numbers at the top and then you repeat the number below. You just write out the number below. You do not add the denominators. Okay, you don't add them. What you just do is pick that denominator. The denominator remains the same, but then you have to add the numerators. So in this case, the numerators we have here are 2 and 1. So you do 2 plus 1 out of the denominator is what? 5. You won't say 5 plus 5. No, just pick 1, 5. So 2 plus 3 gives you, 2 plus 1 gives you 3. So your answer is 3 out of 5. So this is your answer. You can see it's very simple and straightforward. Adding like fractions, very straightforward. So let's take another example. Okay, let's make this plural. Another example would be, let's say 2/7 plus 4/7, right? So again, we see they are the same denominators. That's why they are like fractions in the first place. So first example, second example. What do? You only add the numerators. So 2 and 4 are the numerators. You have 2 plus 4 over the denominator. These denominators of the two fractions are 7. So you're not going to say 7 plus 7. You just pick the 7 and you write it out. So now you have 2 plus 4 is 6, and the denominator is 7. So when you add 2 7ths plus 4 7ths, your answer is 6 7ths. 2 out of 7 plus 4 out of 7 gives you 6 out of 7. Simply add the numerators, and that is all. The same thing applies to subtraction. When you're subtracting, all you need to do is subtract the numerators. But that applies only, like I mentioned earlier, to like fractions. Okay, so let's quickly take some examples of subtraction. So the first one, let's do 5 out of 6 minus 2 out of 6. Okay, so here, like we did in the case of addition, we're simply going to subtract the numerators. Remember, the denominators are the same, so we're not doing anything there. So here you have 5 minus 2 over 6. 5 minus 2 over 6, and 5 minus 2 is what? 3 out of 6. Now I'm going to leave this 3 out of 6 just the way it is, because at a level I don't want to stress you with lowest common factor and stuff like that. Otherwise, when you end up with fractions like this where you can still divide the two numbers, you go ahead till you can divide further. For instance, here 3 can divide 3 and 3 can divide 6. Okay, if you do that, you're actually going to arrive at 1 out of 2. That is half. But for your level, I wouldn't want to stress you. We can just leave this like this. So 5 6 and 2 6, 5 6 minus 2 6 will actually give you 3 6, which is an equivalent fraction to half. It's like half. So let's take this as example 1, and then an example 2, maybe 7 over 11 minus 4 out of 11, 7 11ths minus 4 11ths. So again, we subtract only the numerators and retain the denominator. 7 minus 4 is 3, and that is our answer, 3 11ths, or 3 portions out of 11 total. Wow. I hope we found this interesting and simple and straightforward. Okay, so in our next class, we are going to continue exploring fractions. We're going to see some other aspects of fractions that we need to look into. Like we mentioned, this is just the introduction to fraction. This is the introductory part, okay? And so we are trying to lay some ground, some foundations, so that when other parts of it start coming, we'll be able to have an understanding of where we are going. Please, like I always advise, try to go over this video again, okay, so that you will have a solid understanding of this concept. And you actually need to have a very good understanding of this basic part of it, this foundational part, so that you'll be able to grasp the other parts that will be coming subsequently. Okay, so I hope to see you again next week. Stay blessed and stay safe.